This demonstration begins with a compact 984 PLC controlling a few digital and analog I/O points. The analog input is copied directly to an analog output. First, power is removed from the system. The same power supply is used for the new CERI. The CPU is removed from the rack and replaced with the CERI. Simply connect the power supply and Ethernet. The IP address of the CERI is quickly set through the front panel. Simply use the arrow buttons to drive through a series of menus. First, we'll set the IP address from its default value of 10.10.10.10 to 192.168.1.11. Holding down a button will scroll quickly through its values. Next, we will set the subnet mask. And complete the default gateway. And we are done with the front panel settings. Now we move to a web browser. Enter the IP address of the CERI, choose Configuration, then Control. The IP address of the new Momentum PLC will be set here. This address is 192.168.1.15. Click Update to accept this value. Next, we will configure the rack. Slot 3 holds a 16-bit discrete input card. Choose this card from the list. We will assign this card to holding register 1001. And then click Done. Slot 4 contains a 4-bit relay card. Choose the DAP204 from the list and assign this card to holding register 10. Then click Done. Slot 5 contains the analog input card. Choose the ADU206 from the list. Set the first input to holding register 3001. Set the output to holding register 4010. Now click Update, and then click Configure to set the card's options. This page shows the configuration options for this analog card. To match the old PLC setup, choose Unipolar and 0 to 10 volt 12-bit operation. Then click Done to return to the slot page, and click Done to return to the rack page. Rack 2 Slot 1 holds the analog output card. Select the DAU204 from the list. Register 3006 is fine for the input word. Register 4001 will work for the outputs. Click Update to store these settings, and then click Configuration to set the card options. The old PLC used 0 to 10 volts on each channel with 12-bit scaling. Click Done to accept the new settings and return to the slot page, and click Done to return to the rack page. Rack 2 Slot 2 contains an 8-bit relay card. Select the DAP208 from the list. Set the output to holding register 16, and click Done to return to the rack page. The mapper feature will be used to exactly reproduce the bit numbering used in the old PLC. The first mapper entry unpacks the 4-bit nibble data from holding register 1 into registers 10 through 13. Remember that register 10 is assigned to the 4-bit relay card. The second mapper entry unpacks 8-bit byte data from holding register 1 into registers 15 and 16. Remember that register 16 is assigned to the 8-bit relay card. Now click Store to Flash link to save all of the new settings. Next, we move to ProWorks 32 and open up the old Compact project. We will quickly look at the old traffic cop. Rack 1, Slot 3 had the discrete input card mapped to inputs 1 through 16. Slot 4 had the 4-bit relay card mapped to coils 1 through 8. Slot 5 had the analog input card mapped to 3x registers 1 through 5. Rack 2, Slot 1 had the analog output card mapped to inputs 6 and the output 4x 1 through 5. Slot 2 had the 8-bit relay card mapped to coils 9 through 16. The logic consists of 4 rungs to copy a few inputs to outputs. We will copy this network to paste it into the new Momentum program later. Now make a new project for the Momentum controller. This controller is an M1 97030. And we'll set it up at IP address 192.168.1.15. First, go to the logic section and paste the ladder code from the old program. Now we need to set up the config extensions. We'll make some room for config extensions by setting the size to 200. Now we will select the TCP IP and I/O scanner extensions. The IP address is set to 192.168.1.15. The subnet mask is 255.255.255.0, and the default gate is 192.168.1.1. Enter the PLC's IP address again in the I/O scanner header. Also, change the health block away from 3x1. We need these registers for the analog I/O. Now we need 2 I/O scanner entries. Both entries will use 192.168.1.11 to reach the CERI. The unit ID of 0 and the repetition setting of 0 are both fine. The health timeout should be set to 1000 for 1 second. For this demonstration, set the fallback value to 0. The first scanner entry will read and write the discrete values. Set the read to 1x1. Set the read from to 4x 1001. The length of 1 is correct. Set the write from to 0x1 and set the write to 4x1. The length of 1 is correct. These settings will move the 16 input bits from the CERI to PLC inputs 1 through 16. It also moves PLC coils 1 through 16 to holding register 1 in the CERI, where the mapper entries will split the bits back out to the appropriate card. The second scanner entry will copy the analog inputs and outputs. Again, the target IP address is set to match the CERI. Again, the health timeout is 1000. The read to is set to 3x1. The read from is set to 4x 3001, and the count is set to 6 words. The write to is set to 4x1. The write from is set to 4x 4001, and the count is 4 words. Now, save the project. And write the project to the PLC. Finally, place the PLC and run. Now we see the new system running just like the original. Please visit niobrara.com for more information.